about graphing systems of inequalities. You've graphed systems where we have two graphs on the same grid, and you've graphed inequalities where we graph the boundary line and shade. We're now just putting these two together. To graph the solution to a system, we need to find the region that satisfies both inequalities. So what we're looking for is the intersection between the two. To do this, what we want to do is graph each line and lightly shade, and then we can find the common region. So let's take this first one. We have x is greater than -3. This is going to be a vertical line going through -3. And since we have greater than as opposed to greater than and or equal to, we're going to use a dotted line. To show that it would be greater than, we're going to shade the numbers where x is greater than -3. So this is going to be to the right of the inequality boundary line. So here we've lightly shaded to show this one. You don't want to shade too heavily or your graph becomes a big mess. So now let's take the second one. We have a y-intercept of +1 and a slope of 1. So we're going to count up 1 over 1. And again, this is going to be a dotted line since we do not have the or equal to. And then our shading, because it's greater than, will also be above, like this. Notice that you have one region on your graph where the two shading overlap. This region right here has both the red shading and the blue shading, so it's the solution to our inequality. So you're going to highlight or otherwise shade that to show that that is your final answer. For the next example, we're going to need to solve for y. So we're going to move our 2x over, and that's going to make y less than -2x plus 1. Which gives us a y-intercept of 1 and a slope of -2. So we're going to go down 2 over 1. Think about whether or not this line should be solid or dotted. Because we do not have or equal to, it should be a dotted line. Again, consider your shading. We have a less than, so we should be shading below the line like this. Next line, the next inequality, we need to solve again for y. So we're going to move our x across, and when we divide by -1, don't forget to reverse the direction of your inequality. So we have a y-intercept of -3 and a slope of +1. This time we have the or equal to, so we're going to have a solid line. The graphing form of the equation or the inequality is a greater than, so our shading should be above the boundary line. Do you see the region where the two shadings overlap? This region right here is your final answer. So we're going to highlight to show that this is our solution. Now we have 3 inequalities. This isn't any different. We just are going to have 3 different boundaries on our graph and find one region that satisfies all 3. The line x is greater than or equal to 0 is simply going to be cutting through the x-axis at 0. This is the equation of the y-axis, so it's going to go right here. You should extend your arrows a little beyond the grid so you can see that you have a line there. Our shading would be to the right because it's greater than. Our next line is y is less than or equal to 2, and that's going to be a horizontal line going through the y-axis at 2 with our shading below. Our next line has a y-intercept of 4 and a slope of -1/2. So we're going to get that line in place. And then we're going to consider solid or dotted again. This one is going to be solid. And so here's this line. Our shading for this should be below. And so we find that our final region runs right in here. This is where the 3 regions overlap. Sometimes these graphs get a little messy and it's hard to see, but you can usually just note the sections that you need to graph. Okay, your turn. I want you to stop the video, and I want you to graph this system of inequalities. Don't forget to solve the last 2 inequalities for y. Graph and shade your final region. When you're finished, start the video again to check your work. Check the placement of your lines. They should be as you see here. We need to be below the green line. We need to be to the left of the purple line. We need to be below the blue line. and we need to be above the red line. That's going to leave us in this little region right here. The next example includes both a line and an absolute value graph. Think carefully about how you graph your absolute value. We'll start with the line. Solving for y, we're going to get 2y is less than negative x plus 4. Dividing by 2, we'll get y is less than negative 1/2 x plus 2. So we're going to start on the y-axis at 2, go down 1 and over 2. And think about solid versus dotted. This should be a dotted line. And our shading would be below this line. Now let's look at our absolute value. Think carefully about where your new origin point would be. Based on our translations, this would be at 3, -4. So we're going to place our point at 3, -4. We do not have a stretch or compression, so we're going to just count up the sides by 1. And then we're going to think solid versus dotted again, as always. And this one would be a solid line. And then we need to think about the region where these would intersect. Since we have to stay below the blue line and above the red absolute value graph, that's going to put us in this little region right here. But be careful, always assuming that it's going to be the nice, pretty contained region. Sometimes we may change an inequality on you, and you have to really think about where to graph. This last example asks us to look at each point listed below and state whether it's a solution to the inequality. With the graph, this becomes really easy. All we have to do is test to see is the point in the shaded region. So for the point -1, -1, we can look for that on the graph, and it would be right here. Since it is in the shaded region, that point is a solution. On the second graph, when I go to -1, -1, it's outside the shaded region, so it is not a solution. -1, -1, decide whether you think that's a solution or not. Jump down to C at 0, -2. Let's think about that for a minute. If I look at this last graph at 0, -2, I am right on the line. Normally, that would make it a solution, but if you notice the line is dotted, which means we cannot include points on the line. So this one is going to be a no because you have that dotted line. If it were solid, it would be yes. Take a few minutes now and complete this exercise, deciding whether or not the points are solutions to each of the 3 inequalities. When you're finished, go on to the next section and graph those 3 inequalities and do the shading. Your teacher will be checking for those to be complete in class the next time. Happy graphing!